Hello and welcome to a supplementary video reviewing our quadrilaterals. In the previous video we showed that the area of a rhombus is the length squared multiplied by the sine of any of the angles. And just to explain why that is, the opposite angles are the same, and therefore it doesn't matter which of the two you pick, and the adjacent angles are supplementary, that is to say that the two angles add up to 180 degrees. So if one of the angles is x, the other angle is going to be 180 degrees minus x, and the sine of 180 degrees minus x is the same as the sine of x. However, what if on your exam you're not given the length, and what if you're not given any of the angles? What if you're just given the lengths of the diagonals, which are perpendicular bisectors? Okay, so what happens if you're given the perpendicular lengths of or the perpendicular bisector lengths, but you're not given the lengths of the actual rhombus? So for example, if this is the length of the rhombus here, I'm going to put that in black. So if this is the length here, and let's say this is an angle here, you would know how to find the area of the rhombus. But what if you're not given these? What if you're given this length? I'm going to call it P1, P for perpendicular bisector. I'm going to call that P1, and this P2. So P1 is this entire length here, and P2 is this entire length here. So you're given the length of these diagonal perpendicular bisectors, but you're not given the actual length of the rhombus. How would you go about finding the area then? Well, with a little head scratching you could probably work this out for yourself easily enough, but it's worth going to the trouble of explaining in case it does show up on your exam. If we look, I'm going to use another colour, I'm going to use blue. If we look at part of this shape here, I'm going to take this whole diagonal, even though I can't draw in a straight line. I could have used the straight line function, couldn't I? So if we take this, and then we take this length here, and then we take this length here, we've got ourselves a triangle. And we know about triangles. We know that the area of a triangle is equal to a half base times height. Now we know the base of this triangle because that's just P1. And then the height is going to be half of P2 because P2 is the entire length of the diagonal. But we only want half of that because we know this is exactly half of P2 because these are perpendicular bisectors. That means they chop each other exactly in half. So the area of just the triangle is equal to a half of P1 times a half of P2. The first half comes because it's half base times height, and the second one is because the height is a half of P2. Now this length, I'm going to use another colour just so it's obvious what I'm talking about. This length here, this P1 length, actually I'm going to use a nice thick line. This length here is common to this triangle that I made blue, but I'm now going to make whatever this colour is. Now this triangle is the same as this triangle because these legs are all the same length. And this height here, we know because it's a perpendicular bisector, is the same as this height here. So these two triangles are congruent. So the area of the entire rhombus then is just twice the area of one of those triangles, and we know the area of one of those triangles, so the area of the rhombus is equal to 2 times a half times, I'm going to take the other half, times our P1 times P2. Well, 2 times a half is 1, and 1 times anything is itself, so we can cancel out the 2 and we can cancel out one of these halves. So the area of the rhombus is just a half times one of the perpendicular bisectors times the other perpendicular bisectors. So you just take the two diagonals, multiply them together, and then halve your answer, and that gives you the area of the rhombus. So if you find yourself on an exam and you're given the length of the two diagonals, don't sweat trying to derive it, trying to figure out what the lengths are and the angles are so that you can try and work out the area. Just simply multiply the two diagonals together, then halve your answer, and that will give you the area of the rhombus. Okay, I hope you found that helpful. I'd like to wish you all the best with your revision and all the best with your exams. If you liked this video, don't forget to like, comment and subscribe, and I look forward to seeing you in another video.